Good evening. For this program, we're going to talk about the strange little planet Mercury. So first of all, over to Chris Lindsay for a quick rundown.
Have you ever seen Mercury? It's the most elusive of the bright planets because it stays so close to the Sun. It does sometimes pop up in the evening sky, but this month it's a morning object. Mercury is the planet nearest the Sun, and it's a world of extreme temperatures. It's the smallest of the major planets, and it has the oldest surface. It has a large iron core, which accounts for about 2/3 of the planet's mass. And at a glance, it looks a lot like the Moon, with craters and lava seas, but it's got a weak magnetic field and an extremely thin atmosphere. And these false colour images reveal a complex surface chemistry. Although Mercury orbits the Sun very quickly, it's turning very slowly, so that one Mercurian day lasts the equivalent of 176 Earth days. The side facing the Sun gets very hot, over 400 degrees Celsius, while the side facing away from the Sun gets icily cold, minus 180 degrees. It's a world of mysteries. How did it form, and why does it have this large iron core? Mariner 10 was the first spacecraft to fly past Mercury back in the 70s, but with the arrival of Messenger in 2011, we finally had our first spacecraft in orbit. Messenger has sent back stunning images, like this one of the Caloris Basin, the largest impact crater anywhere in the solar system. It's also discovered volcanic vents, and these strange hollows or pits, which give a Swiss cheese appearance where materials vanished into space. The poles of Mercury are also a mystery. We've seen the signature of water in the freezing, permanently shadowed craters at both the North and South poles. For a planet so near the Sun, this certainly challenges our ideas about the solar system. Katie Joy and Dave Rothery have come down to Selsey to talk to us about some of these strange features that we see on Mercury. Messenger's mapped the whole planet by now, but it's still thrown up more questions than it has answers.
Now, first of all, may I come to you, Katie? What's the very latest news from Messenger?
Well, Messenger's been in orbit about 1.5 years now around Mercury, and we're finding out huge amounts of new information from all of the experiments that are running on the spacecraft. So lots of new things about Mercury and understanding the planet that is closest to the Sun.
What about the Mercurian atmosphere, if it has one?
Well, Mercury we've had observations from Earth to suggest that there are atoms around Mercury that form an exosphere, so not necessarily an atmosphere but an exosphere. And some of the instruments on board the spacecraft are helping us to understand the coupling of the exosphere and the planetary surface in a bit more detail.
But of course the atmosphere of Mercury is very, very tenuous.
Extremely tenuous. And it's great for remote sensing of the planetary surface. There's no air in the way, effectively. These atoms are extremely diffuse, but they are there. And the matter of what is recharging them is of considerable interest. There are places on the surface which are quite remarkable, which we didn't expect. When we flew past Mercury, we saw craters with high albedo patches on the floor, bright patches on the floor. I remember discussing them with you, Patrick, and we were scratching our heads. What are these craters with these bright patches? Now we're in orbit around Mercury. You see hollows on the surface. You see something's removing the surface. We don't know how. The only thing we can think of is that the surface material is somehow disappearing to space. Maybe it's subliming, turning from solid to vapour. It's a really strange landform, but this is one way we could get these atoms into the exosphere.
One point though here, people compare Mercury with the Moon. Well, in some stages it's like the Moon, in others totally unlike.
It is. It's very different. I mean, we have the very heavily cratered areas suggest that the Mercury has been bombarded by very large asteroids and comets throughout its history. And we think most of those basins, which are over 300 kilometres in diameter, were probably formed very, very early on in Mercury's history, so prior to about 3.8 billion years ago. And then subsequently to that, we've had volcanism, which has erupted in different areas on the surface of Mercury and flooded very thick lavas into those ancient basins. And this is something that Messenger is taking images of the surface in new detail, that we can study some of these volcanic sites.
Well, we hear about water at the poles of Mercury. I'm a total sceptic. What are you, Chris?
No, I think some of the evidence is convincing. This was first seen, or the first signs of what might be water, Dave, was seen with radar, right?
Yeah, you can image parts of Mercury with radar from the Earth and resolve individual craters. And within some of the polar craters at both poles, there was something which was sending back a strong radar return.
So you've got a strong bounce back.
A strong bounce, something scattered back strongly by something which has properties which could be water ice, could be sulphur.
Mixed up with the soil
With
as
the
well,
regular
right? We're not talking about an ice rink that you could skate on. It's
No,
mixed
I
up
think
with-
wound up in terms of kind of small crystals within the soil.
Water or sulphur are the obvious ones to give this kind of radar return. And we now know these are areas on Mercury where parts of crater floors are in permanent shadow. They're so close to the poles the sun never peers onto the crater floor, so it's very cold all the time.
Yeah, it never gets above about minus 170 centigrade, something like that. A similar effect is
Similar
seen
effect
on the moon.
So again, we have evidence from radar scattering of some of these permanently shadowed craters at the south pole of the moon that they could have some of this water ice properties.
I'm a total skeptic. When someone gives me a cupful of lunar water, then I was wrong.
That'd be a very expensive drink, Patrick.
Very. Well, Dave, Katie, thank you very much.
Thank you.
Well, as we've heard, Patrick, Mercury has many mysteries, and the next spacecraft to try and unravel them is a European one called Bepi Colombo. And that spacecraft, Patrick, is currently in Stevenage being assembled, and Chris North went to take a look.
Astrium have been building satellites in Stevenage for over 40 years. Walking the long corridors with Jessica Marshall, a spacecraft and satellite engineer, I'm reminded how far we've come since 1957, when Sputnik was launched into space. In the Andromeda Lab, there are 3 satellites under construction. This communications satellite will eventually circle the Earth tens of thousands of miles up, beaming down digital television signals. It has the latest satellite technology, and we've been asked not to film any details which competitors might see. It's a small world with closely guarded secrets. But we're here to see this satellite, called Bepi Colombo, which will eventually circle the least understood of the planets in the solar system, Mercury. It's named after the scientist who worked out the best way of getting a spacecraft to this tiny world. The scientific instruments, which will tell us about Mercury's atmosphere, what the planet is made of, and how it was formed, will be fitted onto this structure, the middle section of a 3-part satellite.
So behind us we've got Bepi Colombo, or part of Bepi Colombo. Tell us what we've got here.
So this is the very middle part of Bepi Colombo. It's the planetary orbiter, and it's going to be European scientific module. So all the science instruments will be mounted onto this, and this will be in orbit looking down at the planet. But what you see here is only a third of that, so the whole thing's going to be about the size of a bus.
Right.
On one side will be the transfer module to get the whole stack to Mercury, and on the other side will be another spacecraft which will be looking at the magnetic field around the planet.
Jessica is part of a team spread across Europe and Japan, which is getting Bepi Colombo ready for its long journey and the harsh conditions around the first rock from the sun, where temperatures will reach 350 degrees Celsius.
Because we're so close to the sun and because we're going to heat up so much, we've got to be very accurate to make sure the wrong bits don't point to the sun. So the scientific instruments, we can't point them at the sun. So we have to make sure we're controlling the spacecraft properly. But also, this 6-year journey to get there in itself is a big engineering challenge. So all these modules are stacked together and then spend 6 years going towards the planet. And then after 6 years, we have to separate them. And that's a big challenge for us, because if it doesn't work, then that's going to have, obviously, huge implications on the mission.
Today the engineers are welding together the fuel pipes and putting in valves for the thrusters that will control Bepi Colombo when it gets to Mercury. Unlike its conventional neighbours with their big fuel tanks, Bepi Colombo will be travelling most of the way by ion propulsion.
This is one of the tanks that will contain xenon gas, not your conventional rocket fuel, but for Bepi Colombo it's crucial to its novel ion propulsion engine that when it gets to Mercury is key to slowing the spacecraft down and letting it get into orbit around a tiny planet.
Ion propulsion might sound and look like science fiction, but while it is a relatively new technology, it has been well tested on previous space missions. Once in space, Bepi Colombo's engines will use a steady stream of tiny charged particles of ionised gas to push the spacecraft along. The ion thrusters are being developed in the UK too. This footage from Kinetic in Farnborough shows the distinctive blue plasma produced by ion engines. And while the thrust produced is relatively tiny, ion engines are incredibly efficient and can continue to fire for very long periods of time. They're ideal for a journey that will take more than 6 years and cover several billion miles. And there's one more key difference. For most of the journey, Bepi Colombo's engines will be acting like a brake, counteracting the sun's incredible gravitational pull.
In order to get to Mercury, you've actually got to slow down. So we've got to spiral in towards the sun. And that takes quite a lot of energy to do. In fact, it takes more energy to do that than it does to get us out to Jupiter or Saturn. And that orbit uses the Moon, the Earth and Venus to do gravity assist manoeuvres and to slow us down.
So this is like the slingshots that we think of to get out to the distant reaches of the solar system, but actually slowing you down rather than speeding you up.
Exactly. And it means that we are able to get to Mercury in the most fuel efficient way. We've got to make it as light as possible because if we make it too heavy, A, we won't be able to launch it, but also we won't be able to get it to Mercury, and we want to get to Mercury and do as much science there. The more mass that we save on the structure and propulsion means the more mass we can give to the scientists and they can have bigger and better instruments on board.
Bepi is currently being spun around to allow closer inspection. The Astrium engineers are very careful and rigorous. Bolts are tightened and everything is checked and rechecked. But it's still a tense time. A few years ago, an American company wasn't as careful and dropped a NASA satellite during a similar procedure. Oops. Finally, Bepi is turned over to reveal its huge radiator panel, which will help cool its science instruments and allow the engineers to start work on the next section. Of course, when it gets to launch, it's going to get a far less gentle treatment.
And liftoff of Messenger on NASA's mission to Mercury.
With the launch, it's the worst case environment for a spacecraft. So you think about it being at the top of that rocket and the rocket's lit and it begins to accelerate out of the Earth's environment. It's shaking around, but there's also big acoustic noise, big shock waves that will go through that whole spacecraft. So on Ariane 5, when you release the side boosters, big shock waves going through the spacecraft. We've got to make sure we survive that.
Launch is on schedule for 2015. Not long to get Bepi ready. It's a long time in the planning and will take a long time to get there. But once at Mercury, Bepi Colombo should solve many of the mysteries that Messenger has uncovered. In the meantime, images of Mercury, never before seen, are being sent back all the time. But you don't need a multi-million-pound spacecraft or ion propulsion to get you out of bed in order to appreciate Mercury. This month, it'll be on view from Earth in the early morning, just before sunrise. Back to Patrick's garden, where Pete and Paul can tell us more.
Well, Pete, here we are, and we have a nice little planet in the morning sky, don't we? The planet Mercury, which I've only ever seen once.
Have you really?
Yes.
Well, this is a good opportunity to see Mercury because it's in the morning sky, visible just before the sun comes up, and it's actually joined by 2 other planets.
Oh, yes.
Venus and Saturn, and it's Venus which is really the key to finding Mercury. Venus is sort of moving between Saturn and Mercury over the first couple of weeks of December, but the morning which I'd really recommend is the 11th of December because there's a fantastic little crescent moon there as well which joins the party, and that really sets things off. Now Mercury is the lowest of the dots and it's fainter than Venus, but it's still quite bright.
It is also one of those things that's nice to say you've seen it. Also, we have in December the Geminid meteor shower. Now this is going to be a good one this year, isn't it?
I'm really looking forward to this because this...
The moon's out of the way.
Well, it's new, the moon, on the 13th of December, and that's when the peak of the Geminids is. So what you've got to do on the 13th of December, you must do this, is get yourself a sunbed or a sun lounge or a star lounger, shall we call it.
Star lounge.
And we lie outside sort of just before midnight through to dawn if you can. That's the best time, and you should get a fantastic view of the Geminid meteor shower. The peak rate is about 100 plus meteors per hour.
I want to find somewhere dark away from the city because I wouldn't mind seeing some bright ones myself.
But to be honest, we've had a very poor period of weather, so what I'm going to do is look for some clear skies in the country, and I'm just going to drive to them. And
you can pick me up on the way there and I'll come with you. Well, all of these things present lovely photo opportunities.
They do.
People should go to our Flickr site, www.bbc.co.uk /sky at night. And there also we will find the observing guides written by your good self for the Moor Winter Marathon.
Absolutely.
And that brings us on to our next bit, which is binocular objects. And we have a nice collection of binoculars here. We should perhaps start off by talking a bit about binoculars. And they are really just two little telescopes coupled together, aren't they?
Yes, and some of the objects we've picked for the Moor Winter Marathon are designed to be viewed with just binoculars.
Yeah. We have 8 by 30, and the ones I started with 10 by 50 all the way up to 11 by 80.
That's right, but you don't have to spend a fortune to get a decent pair. Now, the size which you'd normally recommend for astronomy will be either 7 by 50s or 10 by 50s. Now, those numbers, let me explain what they mean. With a 10 by 50 pair of binoculars, that's 10 times magnification and 50mm diameter front lens, basically.
So these 11 by 80s, this will magnify 11 times, and they have 80mm lens.
Which is quite big, because that's over 3 inches.
It is. That is a problem with the bigger binoculars. To hold them steady, you really have to have arms like Popeye to keep them still.
Well, there's that problem, which is an issue. These are actually 15 by 70s, so that's quite a high magnification, 15.
It is, yeah.
So I've got them on a tripod here, and that steadies the binoculars.
This is certainly a good solution. You do have a cheaper method though, don't you?
Well, you can use a broom.
I will not recommend that to anybody, because I tried it once and all of God's creatures, the spiders and slugs, all dropped out. It was a travesty. So.
Yeah, so basically you take the broom and you invert it, so you put the binoculars on the bristles, and then that helps you steady them as you're looking.
Absolutely.
But let's talk about some of the objects which are in the Moor Winter Marathon which we can see with binoculars.
Yes, so let's start with M33, the
yeah.
Triangulum galaxy. The Triangulum spiral, it is a spiral galaxy. It's one of the members of the local group, which comprises of our galaxy, the Andromeda spiral,
yeah.
a couple of others. It is an interesting object, but it does have a very low surface brightness, so quite a hard object, I think.
You can see it with the naked eye if you've got really, really good skies, but the way to guarantee a view is not to use a telescope, because that's got too much magnification.
Yes, yeah.
Is to use a wide field instrument like a pair of binoculars, because that gives you a nice wide part of the sky to look at, collecting all that very delicate light you've got there.
It does come up from nearly 3 million light years
That's
away,
right.
so yeah, it's worth going at.
Interestingly, the way to find it, you normally use the Great Square of Pegasus to find the Andromeda Galaxy. So if you go in the start in the bottom right of the Great Square of Pegasus to the one in the upper left, keep that line going until you come to a star of similar brightness. And then if you turn it at right angles to that, going up the sky, you come to a fainter star, and then a fainter star still next to that. And the Andromeda Galaxy is a faint elongated smudge next to that star.
Right.
Which, if you've got clear dark skies, isn't too difficult to see. If you then draw a line from the Andromeda Galaxy to Mirac and keep going for the same distance again.
Just as well this is in your observing guides, honestly.
But if you draw a line from the Andromeda Galaxy through the main star...
Pete, I'm completely lost.
And go the
Does
other
this ever
way,
have an ending?
and go the other way for the same distance, that points exactly at M33.
Right.
But let's go from something which is outside of our own galaxy to something which is inside our own galaxy, and that's the Beehive cluster,
yeah,
M44.
This is a lovely thing. It's one of those objects, I'm glad you put it in the binocular list, because a telescope just does not do it justice.
Too much power.
Too much power. You really want a low field, small pair of binoculars, and you get all these beautiful stars in this cluster. I'm not a big fan of open clusters, but the Praesepe is a really good one. And of course, actually, quite interestingly, recently, we know that some of the stars within that cluster now hold extrasolar planets.
Yes.
So it's a cluster of interest at the moment.
There's another really nice cluster. I'm really annoying you here, aren't I, with clusters?
No, it's fine. I know you've only put them in to annoy me.
But if you find Orion the Hunter,
Yeah.
which is very easy to see, you
it.
can't miss it. If you find the belt, the 3 stars which make the belt of Orion, and you follow them down to the left, they point to Sirius, the
Yes.
brightest star in the night sky. Well, just below Sirius, if you look at that region with a pair of binoculars, there's a lovely cluster known as Messier 41.
Well, moving away from clusters now, there is a lovely object that you put on the list, and I think this is probably one of the most beautiful things out of the whole thing.
Right.
And that's Kendall's Cascade.
Ah, yes.
And I've seen a few pictures on our Flickr site, so quite a few people have commented that this really is one of sort of those undiscovered objects that it's so easy to find, and yet it's so rewarding when you do find it. You just never think to look for it.
Well, it's in the constellation of Camelopardalis, which is very, very obscure, and it's quite difficult to navigate around there, but I can give you a trick to find it.
Go on then.
Because if you have the W of Cassiopeia, and you join one end of the W to the other towards the left. If you extend that length, the same distance again, that points exactly at Kemble's Cascade.
Yeah.
And that makes it very easy to locate. People can go and find them by using the More Winter Marathon guides and observing forms, which are available via the BBC Sky at Night website.
Well, some lovely things to look for in the More Winter Marathon. All we need is the skies to clear. Did you know, Pete, that this is actually the 40th anniversary of the Apollo 17 mission? So here's Chris Lintott to look at some of the highlights of our last manned expedition to the moon.
10, 9, 8, 7, ignition sequence started. All engines are started. We have ignition, 2, 1, 0. We have a liftoff. We have a liftoff, and it's lighting up the area. It's just like daylight here at Kennedy Space Center as the Saturn V is moving off the pad.
In December 1972, Apollo 17 left for the moon. It was the only nighttime launch of a Saturn V rocket and a spectacular and dramatic sight. Its crew, Ron Evans, geologist Harrison Smith, and the last man to stand on the moon, Commander Eugene Cernan.
We got a beautiful picture, you guys, up down there.
Apollo 17 landed in the Littrow Valley, amongst a range of mountains formed by a huge and ancient impact. It made an ideal site for geological investigation, with layers of ancient bedrock and newer volcanic deposits. The astronauts spent 3 days in all collecting samples, setting up science experiments, and just occasionally having fun.
I was strolling on the moon one day in a merry month of December. May.
Commander Eugene Cernan was an experienced Navy pilot. He first flew into space with Gemini 9, Apollo's predecessor, and then again with Apollo 10. In 1982, Patrick interviewed him for The Sky at Night.
Recently, I went back to Texas to talk to the last man on the moon. What about navigational problems? Did you have any?
We studied, due to a great deal of your work, of course, on the mapping of the moon, we studied the area we were going to land so well that I really believe I knew it, at least from the air, from above, as well as I know my own backyard. But it's hard for me to realize that I literally have been on another planet.
The Littrow Valley did not disappoint. With its dramatic scenery and incredible boulders, the astronauts were kept very busy gathering bore samples and bits of rock. The discovery of orange soil at Shorty Crater was unexpected and exciting.
Hey, there is orange soil. Well, don't move it till I see it. Wait, I put my visor up. It's still orange. Fantastic, sports fans.
The orange soil samples were returned to Earth. High in zinc, these glass beads are now thought to have formed in volcanic vents.
You can see this in your color television, I'll bet you. I'll there be orange soil on the moon.
Eventually, the incredible adventure on the moon was over, and the astronauts had to go home. It ended a remarkable chapter in the history of exploration.
You're the last man on the moon. What are your overall impressions of the moon?
My overall impressions of the moon are really overshadowed by my impressions of looking back at the Earth. The moon itself it's been called like a sandy beach. It's colorless, but it is beautiful. It's majestic. It's got towering mountains, and it's got tremendously overpowering landscape.
Oh, what a nice day. Oh, funny, there's not a cloud in the sky. 3, 2, 1, ignition. Right away, Houston.
The legacy of Apollo 17 still lives on. NASA's Lunar Reconnaissance Orbiter is currently mapping the moon, and it recently imaged the Apollo 17 landing site. You can clearly see the lunar module, the buggy tracks, and even those of the astronauts themselves, just as fresh as they were back in December 1972. With no weathering on the moon, time seemingly stands still. Back on Earth, the samples the astronauts returned are still telling us new things about the moon, our celestial neighbour. Katie Joy's been lucky enough to work with some of these precious relics. Apollo 17 went to a very special place on the moon, probably, I think, the most interesting of the Apollo sites. So why there? What was interesting?
They went to the rim of the Serenitatis impact basin, so one of these really large-scale impact basins on the near side of the moon. And this is the boundary between the edge of that basin and the surrounding highlands areas, where there's a steep valley called the Littrow Valley, which has been subsequently flooded with lavas. And so this was a geologically diverse site. It had both highland rocks, so we could look at the ancient materials on the moon, and also the much younger lavas. So it was to provide as much diversity as possible to try and understand the geological history of the moon.
The scenery there was absolutely magnificent.
They brought back 110 kilograms of moon rock, and this is far more than all of the other Apollo missions. We had the deep drill core on Apollo 17 where they brought up material from 3 meters in depth below the lunar soil, so the lunar regolith, this material that covers the whole surface of the moon. And so this deep drill core provided us with a snapshot back in time through what material was formed at different points in the past with depth. And so that's been really important. But having a scientist there, a geologist, to sort of know where to go, I think, helped a lot, particularly for this latter mission.
18, 19 and 20 would have been geologists, but sadly they never went.
No, the 3 latter missions that were planned but never went. But maybe in the future, so when we go back and explore the surfaces of other planets, there'll be more scientists that will have the opportunity to interact and to go and to sample the surface.
Well, I volunteer for starters.
There we go.
If you need an astronomer, then that's good.
I would love to have gone. I knew after that, no chance.
What would you say are the real scientific legacies of the Apollo program? Maybe not just Apollo 17, but as a whole.
Yeah, many of the samples are still being studied in laboratories around the Earth. So as technology has increased through the past 40 years, we can study smaller and smaller amounts and find out new types of information. I mean, one of the really interesting things that's come out of these particular orange soils that Apollo 17 sampled was the identification that they were rich in water, suggesting that the lunar interior is actually relatively, well, a lot wetter than we thought it was, which helps us to understand the internal structure of the moon and where these sorts of volatiles come from. And that's only been sort of rediscovered, if you like, within the last 5 years or so. But we also placed a series of experiments on the surface. So the ALSEP packages, which are in situ experiments that were left on the surface of the moon to conduct science and that lasted after the astronauts left. So we have seismic information which provides us about the variation.
So looking for moonquakes.
Moonquakes, exactly, yeah, from this particular site, but also understanding the local heat flow, so the thermal environment of the moon, and placing these retroreflectors where we shine lasers up from Earth to understand how the moon is moving away from us as well. So lots of good geology from the rocks, but lots of good surface science experiments as well.
Well, Katie, thank you very much indeed.
When we return this rock, or some of the others like it to Houston, we'd like to share a piece of this rock with so many of the countries throughout the world. We hope that this will be a symbol of what our feelings are, what the feelings of the Apollo program are, and a symbol of mankind that we can live in peace and harmony in the future.
Well, Patrick, one more thing we have to talk about before we go. There was a total eclipse of the sun from Australia a few weeks ago. Beautifully clear over most of the eclipse track and some great photos, including this video sequence I've been sent showing the sequences of the eclipse and totality itself, with the pearly white corona, the sun's outer atmosphere shining out in what looks like a glorious eclipse. And don't you wish we'd been there?
I wish we had.
Next time.
Have you got a new telescope, or are you going to get one for Christmas? Next month, I will give you a few tips about how to set it up and how to use it. Until then, good night.